This lesson is part of a series of training videos where we will look at a specific product in a specific installation, comparing our installation instructions and good practice with actual conditions on a job site. The primary goal is to help you become more familiar with our products, enabling you to tell if they have been installed correctly and if they're doing what they're supposed to be doing. Along the way, we'll also discuss what's important for when we need to determine if something is close enough, what's dangerous for when we need to bring something to the contractor's immediate attention, and why our products are used the way they're used. These videos will assume you're already somewhat familiar with the products being discussed. If you haven't already done so, please take some time to watch our other product training videos that go into detail on our various products' features and components. Vibro-Acoustics creates noise control solutions for the HVAC industry, addressing both airborne and structure-borne transmission paths. Our vibration isolation products help mitigate equipment vibrations that could cause noise problems in buildings. In this lesson, we will look at neoprene pad isolators installed under an indoor air handling unit with internal spring isolation on its fan. In mid-2015, Vibro-Acoustics secured a vibration isolation order for a project in downtown Toronto called the Axiom Condominiums, with multiple pieces of equipment and piping. The mechanical penthouse of the East Tower included various pieces of equipment, including a fresh air supply air handling unit called FA3, located here in this room. This is the air handling unit submittal. It provides information to the contractor and to us on the unit construction, configuration, dimensions, and weight. The unit is designed to move 15,000 CFM, or cubic feet per minute, of fresh air into the building. It includes multiple sections and weighs a total of 4,784 pounds. The product drawing page shows that it comes in two sections, but does not show completely what the bottom of the unit looks like. We don't know how wide the bearing surfaces of the base rails are. This page from the submittal provides details on the fan section. It is here that we find that the unit comes with 2-inch deflection spring isolators under the fan and motor, which is why we call it internally isolated. As required by the project documents and as recommended by the acoustical consultant, this air handling unit is supported on neoprene pad isolators. Neoprene pads were selected to match the air handling unit weight and bearing surfaces located around the unit perimeter. This is a page from the submittal we provided for some of the equipment on this project, a datasheet for N and NSN neoprene pad isolators. Note that our NSN pad isolators have been superseded by a much better neoprene pad product called Neo Plus. Here is the Neo Plus datasheet and installation instructions. Remember that the most recent versions of all datasheets and installation instructions are available on our website. They are often subject to changes and improvements, so always refer to the latest for the most up-to-date information. But this project specified NSN pads, so let's take a closer look at the datasheet for this isolator and discuss some key things we'll want to look for when we visit the job site. In a previous training video, we went over the various features of N and NSN neoprene pad isolators and explained their appropriate uses. As with other isolator datasheets, this graphic here is meant to help familiarize the contractor with the features and overall dimensions of the product. Neoprene pad isolators are the least expensive isolation products for floor-mounted equipment, but they are often left out or replaced with alternate products. Since the isolators are supposed to be NSN isolators, we'll want to check that they look similar to this image here, that there are 2 layers of ribbed neoprene pads with a layer of steel in the middle. There are no installation instructions with N or NSN pad isolators and few notes to give guidance to the installing contractor. The only notes on this datasheet provide descriptions of the materials used in the different isolator models. This section here provides guidance on sizing and selecting the pads to ensure they are loaded enough to provide some vibration isolation and not overloaded where they would fail or become ineffective. There are design loads and deflections as well as ranges defined by minimum and maximum loads and deflections. These values are used not only in selecting appropriate pad sizes, but also if there is a problem on the job site, we can check the dimensions of the loaded area and calculate the pressure to compare with these values. The N and NSN pad isolators came in 2 different durometers, a measure of their relative hardness. These pads were supplied in either 45 or 65 durometer. The higher the number, the higher the load that could be supported for the same size pad. Our newer Neo Plus pads also come in 2 different durometers. If there were a problem on a job site or a concern about which pads were installed, the durometer of the pads could be measured using a device also called a durometer. It is simply a handheld instrument with a spring-loaded pin connected to a dial indicator. Pushing the pin into the rubber material moves the dial to show the durometer value. Let's consider the plan view of isolator locations. This graphic shows which isolator goes where on the equipment. Typically with neoprene pads, the locations are evenly distributed around the perimeter of the equipment. With any equipment mounted on isolators, it is also important to match the equipment's capability to be supported at specific points. In this case, the designer showed 4 pads on the long sides and an additional pad in the center of each short side. As is typical, all the pad sizes and durometers were the same, here shown to be 3 inches by 3 inches and 65 durometer. As we'll see in a moment, the typical bearing surface of the unit base is about 2 inches wide, so unless there is an additional load distribution plate placed on top of the pad, there will only be a strip of about 2 inches wide that supports the unit at that location. So in this case, 2 inches wide by 3 inches long is 6 square inches, and there are 10 pads, or 60 square inches of pads supporting 4,784 pounds, which means there are about 80 pounds per square inch, which is right in line with the acceptable load range for a 65 durometer pad. If there were only 8 pads, the load would be about 100 pounds per square inch, which is still okay for these pads, but fewer pads may not provide adequate support for the unit. Note that the design load capacity shown in the table above assumes the entire pad is equally loaded. We've selected 3x3 pads on this project, which can support approximately 800 pounds if all 9 square inches are equally loaded, but since that's not the case, we need to do the math to determine the load per square inch. Since N and NSN pads could be made to any size, you may be wondering why we selected 3x3 pads instead of 2x3 pads if we knew or assumed that the unit is only 2 inches wide at the bottom bearing surface. There are a couple of reasons. One is that 3x3 pads and steel plates were stocked items, making it easiest to supply as a standard size. The other is because pads are easier to install when they are slightly wider than the equipment base. This allows for minor misalignments and so helping to ensure that the unit sits on the expected amount of pad. Now that we've discussed the information on the submittal datasheet, we're ready to go look at the installation on the job site. Here again is the 15,000 CFM fresh air handling unit in the east tower of the Axiom condominiums. Let's take a walk around to get a closer look. We'll start in the opposite corner on the other side of the unit. I'll play the video straight through with a running commentary, and then we'll go back and look more closely at a couple of the isolators to discuss what we find. This is the outside air duct connected to the unit air intake. As is typical with most air handling units, this casing is a sheet metal box built on a formed sheet metal base rail frame. Here we can see the black pad isolators under the unit, but notice that there are only 3 under the long side. The corner isolator is in a good location, supporting both the long and short sides of the unit, and there is a pad in the short side center, but these aren't NSN isolators. Lowering the camera, we can see light under the unit, indicating it is not touching the floor. Since there are no seismic restraint requirements here, there are no brackets or anchors to hold the unit down. As we walk past the middle isolator, we can see that there is a shipping split there and that both parts of the unit are resting on the pad, which is a good way to provide support. Now at the end of the unit where the supply fan is located, we see 3 pads across the short side, appropriately located at the corners and in the middle. As we walk around the corner, we can see that the pad here is nice and square with the unit. We'll look at it more closely in a moment. And we see another pad under the shipping split just like the other side. This side of the unit has the water coil pipe connections as well as the access doors to service the unit, which will open shortly. Let's take a closer look at one of the pad isolators. This mystery pad isolator is not one of ours. It appears to be at least 3 inches by 3 inches, possibly 4 inches by 4 inches, and of an unknown material or durometer. I didn't have a tape measure or a durometer with me during the site visit to check its size or hardness. It is obviously not one of our N or NSN pads, as the ribs are all the same height and there is no second pad with a steel plate intermediate layer. It does appear to be neoprene and about 3/8 of an inch thick, similar to our N pads, but since it is only a single layer, it cannot provide the same amount of deflection that 2 layers would provide. The loaded area of the pad appears to be appropriate and the exposed edges are not curled up, which can happen due to excessive loads. These pads look similar to what we would have expected if they had used one of our single-layer N-pad isolators. The corner of the air handling unit appears to be slightly bent, possibly damaged during shipping or installation, but one of the benefits of using neoprene pad isolators is that they can accommodate slight imperfections like this. This kind of imperfection is one of the reasons why thicker or 2-layer pads are specified. Taking a look at another corner of the air handling unit, we see a similar problem, but here the corner was bent up so that it is not in contact with the pad at all. Only the short side base rail is resting on the pad. So what do you think? Was it okay? Was there anything dangerous? And do we need to say anything to the contractor? Well, the first and foremost problem is that the pad isolators are not NSN pads as was shown in the submittal. In preparing for this video, I was unable to find out if these were removed from the order, as it appears the contractor chose to use another supplier. So that issue would have to be resolved first before offering any comments at all. It would be interesting to find out if the engineer or acoustical consultant approved the substitution, since the installed pad isolators are thinner than NSN pads and therefore cannot provide the same amount of deflection or vibration isolation performance. However, in this specific application on an air handling unit with an internally spring-isolated fan, there is typically very little vibration left in the casing that could cause a noise problem. So unless there was a known problem, there would be no practical reason to ask the contractor to replace the isolators. But for the sake of learning, let's review the installation as if the pads were ours. There are only a few questions to consider. Are the correct isolators in the correct places? Well, no, since the pads are not double-layer NSN pads and there are only 8, not 10, as shown in our submittal. However, the placement of the pads is neat and tidy, and if the mystery pads can accommodate the loads and there are no noise or vibration problems, then it could be okay as is. Are the pads loaded okay, not under or overloaded? I'd say they are generally okay. These pads appear to be in good condition with no curling. They did not appear to be overloaded. There were a couple of places where the unit base wasn't sitting flat on the pads due to minor damage, but I'd say it's generally okay. Is the unit floating? Yes. We saw light under the unit and so can assume that there is no direct contact between the unit and the floor, which would short-circuit the vibration isolation. Now that we've finished reviewing the external pad isolators, let's open that access door and take a look at the internal spring isolators under the fan. Starting at the top, we can see the black flexible duct connector on the discharge of the fan, which is a belt-driven double-width double-inlet fan. Both the fan and motor are mounted on a common steel base supported by 2-inch deflection open floor springs. We can see that the base is not resting on the floor rails and appears to be floating. A quick way to check is to gently push on the isolated base to try to make it move. As you can see, I was able to make it shake around, confirming that the base is floating freely. A couple more things I'd like to point out. Notice that there are no restraints. These are not seismically rated springs, as there are no snubbers or anything to restrict the lateral or vertical movement of the base. If this project had seismic requirements, we may have needed to bring this up as a deficiency. The other thing to notice is that the hold-down bolts used during shipping that go in these two holes have obviously been removed. It is not uncommon, however, to find installed units with their shipping bolts still in place. Had they been there, they could have created short-circuit paths for structure-borne vibration noise. So that wraps it up. If these had been our isolators, we could have deemed the installation close enough and okay as is. If there had been any noise or vibration problems, we could have helped provide our feedback on the installation and offered to add the originally specified NSN pads back onto the order. In this lesson, we've looked closely at the datasheet for neoprene pad isolators, types N and NSN, in the context of performing a site inspection where pad isolators were used to support an indoor air handling unit. We discussed various items to look for during an inspection and assessed whether the installation was generally adequate to provide the expected amount of vibration isolation. I hope through this lesson you've become more familiar with neoprene pad isolators and their use.